Hi children, today's chemistry topic is dinitrogen. Dinitrogen formula it is N2. You know that N2 it is existing as a diatomic molecule in the form of N triple bond N. So it is called, the nitrogen gas is also called as dinitrogen. Then you know that the group 15 family, nitrogen, phosphorus, arsenic, antimony, bismuth. So this nitrogen is the first member of this group 15 family, and this nitrogen it was discovered by Daniel Rutherford in 1772. In this chapter we are going to be discuss about the preparation of this dinitrogen and the properties of dinitrogen. Okay. First one, preparation of dinitrogen. So commercial method of preparation and laboratory method of preparation both are different. Commercial method of preparation, that method you studied in the 9th standard. So that method is fractional distillation method. Fractionating column you have to be take it. So small beads all it will be there. Then pass the air through it. And from that lower boiling point 1 that will be escaped through this delivery tube, and it will be collecting first. Compared to the air means lot of other gases also there. So in the case of nitrogen it is having lower boiling point compared to that of other members in that air. Right. So boiling point of nitrogen it is 77.2 Kelvin. So that will be that when we applying the temperature to this fractionating column, so lower boiling point it will be attaining first now. So that lower boiling point nitrogen it will be go through this delivery tube and it collects first as in the form of a liquid dinitrogen. That is the commercial method of preparation. The method we are saying the liquefaction and fractionate distillation of air. Liquid oxygen and liquid nitrogen, likewise liquid contents we are getting. Okay, so here we need nitrogen. Nitrogen it is having the lower boiling point, so that's why it comes first in this beaker and you can collect it first. The next one, laboratory method of preparation. Here we are mainly using three methods of preparation. First one, aqueous solution of ammonium chloride. Ammonium chloride is this one. Yes, ammonium chloride and also sodium nitrite. The sodium nitrite we will use in the chemistry lab for the organic chemistry portions. Organic chemistry, that dye preparation for that we will use it. Sodium nitrite. When this reaction, it results the dinitrogen formation. How this nitrogen N2 we need. So this nitrogen and this nitrogen it combines to form N2 first. Then 2H2O, because here H4 times. So 2H2 and here 2 oxygen. So when 1 oxygen be taken, so 2H2O it is removed from this. Okay. Then remaining thing it is NaCl. Along with these products there is a small amounts of NO and HNO3 also forming in this reaction as a side products. Okay. We have to be remove all other contents other than nitrogen. So for that one method it's there. After the reaction, what the product we are getting, that is in the form of a gaseous form. So that gas just passing over aqueous sulfuric acid. Sulfuric acid, you know that HO2SO4, it's aqueous form containing K2Cr2O7. Such a mixture you have to be take it, and through that medium, the gas which is getting after this reaction, we pass it. So automatically all the impurities due to different chemical reactions we can remove it. At the same time nitrogen it is remaining as dinitrogen. Okay, that is the first laboratory method of preparation. And the second one, that is also very simple one, thermal decomposition of. Thermal decomposition means, thermal means heating. So due to heating there is a decomposition. Decomposition means splitting. It will be happen. So which one's splitting here we are conducting? Ammonium dichromate. Dichromate you know that Cr2O7, that it is dichromate. When it is a potassium dichromate it is K2Cr2O7. When it is ammonium, in place of this K you have to be write ammonium. So here NH4 is the ammonium's formula. Ammonia is NH3. Ammonium NH4 positive. Okay. So here NH4 positive, this portion it is negative. Yes. So ammonium dichromate on thermal decomposition means heating. So at that time the splitting it will be happen. So how the way splitting it is occurring here? here we need dinitrogen. So nitrogen as such. Right? Then 8 hydrogen. So 8 hydrogen, it's the, then how many oxygen it is? The 7 oxygen. So what the thing we can do? 8 hydrogen, 7 oxygen, 2 chromium. So Cr2O3, you have to be 2 chromium now. 2 Cr and 3 oxygen from this. So how many oxygen it is remaining? 4 oxygen. So 8 hydrogen and 4 oxygen. So you can write like this, 4H2O. So 8 and 4. So likewise, the easiest method for remembering this condense or chemical reaction, for that only I said like this. It's not the mechanism, just understanding easiness only. So N2 you have to be removed, Cr2O3 you have to be removed, 4H2O also you have to be removed. So at that time you will get the dinitrogen as a product. The next method, it is very important one. From this method, from azides we are preparing dinitrogen. By the method of this chemical reaction, you will get the dinitrogen, that is very highly pure one. How the it is getting? By the chemical reaction of the thermal decomposition. Thermal decomposition means with the help of heating the compound, it is having splitting. So decomposing. Then barium azide is this one, right? BaN3. BN3, it is said to be azide. Barium azide means barium 2 plus. So N3, there is 2 minus also needed. So for that we are applying it as 2. Okay. So BN3 twice is the barium azide. On thermal heating, what happens? Here splitting occurs. 6 nitrogen it's there, that it is we need dinitrogen. So 3 molecules of nitrogen. Dinitrogen it is formed. From barium azide or sodium azide, you can prepare this dinitrogen. Due to this method of preparation of this dinitrogen, it is highly pure one. So it is very important chemical reaction. So we mainly discussed 3 laboratory method of preparation and also 1 commercial method of preparation. Okay. Next one, properties. So many properties you knows it because we studied about the nitrogen from the early classes onwards. Almost the earth, it consists of 78% of the nitrogen. Okay, then this nitrogen is a colorless, odorless, tasteless and non-toxic gas. Okay, the next one about nitrogen, when we are saying it is lighter than air, slightly lighter than air, and it is sparingly soluble in water. The measurement, it is given 23 ml per liter of water at 0 degree centigrade and 1 bar pressure. That means solubility only the. Next one, freezing and boiling point. Boiling point, it is at 77.2 Kelvin and freezing point is at 63.2 Kelvin. So that means law of freezing and boiling point for this nitrogen. And next one, the property of this nitrogen, it can exist in 2 isotopic forms, just like carbon, etc. Yes, nitrogen, its atomic number is 7, mass number is 14. Nitrogen atomic number is 7, mass number is 15. So what is the thing? These are the 2 isotopes. Why it is said to be isotope? Their atomic number is the same, mass number is only different. So that's why we can say that these are the 2 isotopes of nitrogen. Reactivity of dinitrogen. Dinitrogen, it is said to be chemically inert, non-reactive at ordinary temperature. But when temperature increases, its reactivity also increases. Why it is non-reactive in room temperature? Because of 2 reasons. It is having small size, because you know that atomic number is 7. So compared to the other members in the family, this nitrogen, it is having small size. And you know that the structure, it is N triple bond N. So what's the bond order? 3 bonds between them. So bond order, it is said to be 3. Bond length, it is 109.8 picometer. So this is said to be the nitrogen, it is said to be so stable one. And you know that the bond enthalpy, it is 946. So high bond dissociation enthalpy also needed. So you know that N triple bond N, this is so stable one, and for this breaking we need to be apply large amount of energy. So if it is such a stable one, it is said to be not reactive so much, it is said to be inert at room temperature. But when temperature increases, its reactivity also increases. Then at high temperature, what all reactions we can write? At high temperature, this nitrogen, it reacts with metals to form ionic nitrides. But with the non-metals, you know that in the periodic table, metal session, non-metal session and all we discussed. So the lithium, sodium, potassium and all belongs to the metal section. At the same time, oxygen, nitrogen, fluorine and all that belongs to the non-metal section. So when it reacts with the metal, it results ionic bond, ionic bond, covalent bond, all you studied. So ionic nitrides. Then with non-metals, here oxygen, with that you will get covalent nitrides. So we can discuss on some reactions now. So that lithium, it is a metal. When it reacts with the nitrogen, lithium nitride is the product formed here. Right. So we already discussed that nitrogen is in the oxidation state of -3. So here +1 for the lithium because it is alkali metal. So +1 first group. So lithium, sodium, potassium, etc. So that one, it is having the +1 oxidation state. So when we applying this +1, this is for -3. That's why the lithium here we taken 3 times. Okay. Then magnesium, it is in the +2 oxidation state. In the elemental form, it is having 0. But in the case of compound, you know that it is having +2. So this nitrogen is also having -3. That's why here Mg we written as 3 times. Okay. So this is about the ionic nitrides of these metals with nitrogen combination. Next one, with the non-metals, it forms covalent nitrides. I said no. So example, Haber process is an example. Haber process, you studied that. It is the method we are using for the preparation of ammonia. Ammonia means NH3. So hydrogen and nitrogen, it is combining. And hydrogen, here we considered it as a non-metal. Yes. Nitrogen, hydrogen, due to this combination in the presence of a catalyst iron plus molybdenum. Here molybdenum, it is used as a promoter. At 773 Kelvin, it results to NH3, that it is ammonia. So this is what ammonia here formed. No, it is a covalent nitride. Then with oxygen, that means nitrogen with oxygen. Oxygen here, it is a non-metal. It combines. In the presence of 2000 Kelvin, it results nitric oxide, NO. Yes, this is one example of covalent nitrides. This nitric oxide formation, it is mainly occurring during lightning. Okay, next one, uses. Many important uses for this nitrogen. Nitrogen gases, it is mainly used for the manufacturing of ammonia. Haber process we said. Not only that, nitric acid preparation and also calcium cyanamide. Calcium cyanamide is an industrial chemical that contains nitrogen. Calcium cyanamide, it is one of the important industrial chemical. The next one, from the shops, when you collect the chips and all, inside of the chips for as a preservative, the nitrogen gas, it is filled. Why? Because this nitrogen, it is having inert nature. So for providing such an inert atmosphere in the case of the food items, that means, I said no, food items, then not only that, cryosurgery and also just like a refrigerant, to preserve the biological materials, for that also this dinitrogen it is using. What's the reason? Because it is having inert nature at room temperature. But temperature increases, that time only there is a chance of undergoing the chemical reactions. Okay, then next one, another thing, to create the inert atmosphere in the case of metallurgical processes. Metallurgical process, you know that the iron extraction, likewise different extractions, metal extractions, we studied that. So example, iron and steel industry, inert diluent for reactive minerals. So for that, different chemical reactions for creating the inert atmosphere, this dinitrogen we are using at room temperature. Okay.